Okay, the next part, we're going to speak about types of chemical reactions. So there are five major types of chemical reactions, which are combination or composition reactions, decomposition reactions, combustion reactions, substitution or single replacement, or sometimes it calls displacement reactions, or double replacement or displacement reactions. So, and our goal is to understand what uh, every type of chemical reaction means, and you will be able to recognize types of reaction when you see the equation in front of you. So the first of all, composition or combination reactions. It's a very simple reactions. It's kind of their way of naming like synthesis reaction. So for composition reactions, you need two or more compounds, initial compounds, and you remember that left side, that substances on the left side are called reactants, right? Reactants. Okay. And when two or more substances react with each other, they produce one more complex substance. So it will be two or more reactants and one product. For example, when you see something like, okay, lithium plus oxygen, and lithium oxide is being produced. So this is a type of composition reaction. And warning, it's not balanced, and we need to balance it anyway, because equations shows us the conservation of matter law, right? So, and for example, we need to start with metal. So 2 in front of lithium gives us equal amount of lithium on the both side. But when we calculate amount of oxygen, we will see that 2 here and only 1 here. That means that we need to put additional coefficient on the right side before lithium to O formula, right? And that will change the amount of lithium. So that gives us 4, and the correct way of this equation will be 4 lithium plus oxygen gives us arrow or separate reactants out of products, 2 lithium, 2 O. And you need to recalculate atoms, right? So let's do it together. For lithium at the left, on the left, and for lithium on the right, and two oxygen and two oxygen. So it's completely balanced. I'm sorry. So we have here the example of composition reactions, and you can see that two simple compounds, two pure substances, two elements reacts with each other, and um, more complex substance is being formed, right? So, but sometimes not only elements can react with each other. For example, it's calcium oxide can react with CO2, carbon dioxide, and the name are the rules of naming compounds are different for ionic and covalent compounds, right? So CaO, I will name it just calcium oxide because it's ionic compound, but for CO2 I am going to name it carbon dioxide because it's covalent compound, just to remind you. Okay, so and two substances react with each other and one substance formed. So two reactants and one product, right? So this is the first type of reaction of reactions, composition or combination reactions. So two or more substances react to form one more complex substance. The next one. Oh, I'm sorry. The next one is decomposition reactions. They are opposite to composition. So in a general way, we can show that it's a kind of something like that. We have one complex compound at the left side as a reactant, and at the right side we have two or more simple compounds, right? So let me give you some examples. So CaCO3 calcium carbonate being heated, decomposed by calcium oxide and CO2 carbon dioxide, right? So one reactant and two or more, and in this case there are two, so two products. Okay, do you think this equation is balanced? Let's check it. So calcium, one calcium and one calcium on the right side. Okay, one carbon and one carbon. So carbon is balanced, and three oxygen and three oxygen. So oxygen is balanced too. So the total equation is balanced. Okay. For example, there are you have a link for decomposition of this compound video experiment. So it's ammonia dichromate, and when you heat this compound, it decomposes in three substances. Okay, the first one is nitrogen, diatomic nitrogen. The second one is Cr2O3, and as a ionic compound, it needs to be named like chromium 3 oxide, right? And then H2O. Okay, and we need to balance this equation. So for nitrogen, or for metal, we will start with metal. So chromium is metal. Two chromium at the left side, right? I'm going to underline it, and two chromium here on the right side. We're good with chromium. Then non-metals. Non-metals, the first one we will balance nitrogen. So nitrogen, two nitrogens here because these subscript 2 with parentheses shows us that amount of nitrogen is doubled and amount of hydrogen is doubled too. So two nitrogen right here and two nitrogens atoms here. Eight hydrogens. So, and only two hydrogens are at the at the right side. I'm sorry. So we need to put coefficient 4 to make the amount equal, right? So I will underline it, and we need to recalculate oxygens, right? So on the left side there are 7 oxygens, and on the right side there are 7 oxygens too. So this equation is completely balanced too. And this is a great example of decomposition reactions. So one reactant and 3 products. So to summarize, decomposition reactions: one reactant and 3 products. The next one. The next one is single replacement or substitution reaction. So for these type of reactions, I will use these like general way to how to say, to picture them. A plus B C. So and this equation shows us that we have pure substance and element A, right? And we have a compound which formed out of 2 or more elements. So we have one element and we have a compound. At the left side as a reactant. Reactants, and what is going on in this reaction? So B is being substituted by A. So A kicking out this B and stay at its position. So B going to be just single, lonely, single, boring, pure element, right? And A will join C on a position B. Okay, so and we can see in this way to write these reactions that A substituted B. So we have 2 reactants and we have 2 products. Examples. Examples, there are different, there are numerous examples for these reactions. So, for example, copper can substitute silver in its aqua solution, so solid copper and solution of silver nitrate reacts with each other, and copper stay in a position of silver here. So, and substituted it. And pay attention, copper here will have a charge 2 positive, and NO3, according to solubility chart, has a charge negative, and you know that number of positive and negative charges has to be the same to cancel each other, because generally substances, compounds are neutral, right? So we have 2 positive here, and we have just 1 negative that gives us necessity to put additional subscript here for the whole part NO3 2 times. Now it's balanced, because when I put a subscript here too, that means that I have 2 negative charge here and they cancel each other, right? And copper substituted silver, so and now silver, I mean Ag, is being just single, just an element, right? So this is the type of single replacement or substitution reactions, and we will have a lab about this, and we will use a special chart which shows us reactivity of metals. I mean, less active metals can be substituted by more active metals, and we will talk about that more on our next class. So but pay attention, guys, this equation is not balanced too, so we need to balance it, right? So we will start with metals. Two of them, we can start with any of them. So copper, Cu, one atom on the left side, and copper, one atom on the right side. I underlined both of them, so they are balanced, right? So silver, Ag, one and one, so they are balanced too. For now, I just underlined them and let's check for non-metals. So non-metals, instead of oxygen, we balance oxygen at the end as a final element, right? So nitrogen, one nitrogen at the left side, and two nitrogen, because this subscript applies to nitrogen and oxygen both, because they are into parentheses. So two nitrogens here, that gives us two, coefficient 2, I need to put it in front of AgNO3, in front of silver nitrate. And I am going to underline it. So this now formula is good. But see, this 2, coefficient 2 applies to silver, to Ag. That means that I need to put additional 2 here. And silver is balanced, right? So, and we just recount all atoms, right? As a last step, we recount all metals. So let's start from the beginning. Copper, 1 and 1, good. Silver, 2 and 2, good. Nitrogen, 2 and 2, good. And what about oxygen? 2 times 3, 6, and 3 times 2, 6 oxygen on the both sides. So this reaction, this equation is balanced. The next type of reaction